Have you ever wondered what a 100% fresh air handling unit actually does, and why it requires such a high cooling capacity? Unlike conventional systems that recirculate indoor air, a fresh air AHU works entirely with outdoor air. That means it has to handle higher temperatures, higher humidity, and a much heavier cooling load. Because of this, calculating the cooling capacity for a fresh air system becomes very important, and slightly different from standard HVAC calculations. In this video, I'm going to show you exactly how to calculate the total cooling capacity for a 100% fresh air handling unit, using real weather data and a simple step-by-step method. Let's get started. In this video, we will discuss how to determine the total cooling capacity for a 100% fresh air handling unit. To calculate the total cooling capacity, we first need the outdoor air conditions of the city for which we are performing the fresh air cooling load calculation, and for this, we can use ASHRAE weather data. You can access it from the ASHRAE website, where you simply locate your city on the map, right-click on it, select the relevant weather station, and click on the print option to open the weather data table. From this table, we determine the required weather conditions, and in our case, we will use the dehumidification dew point with mean coincident dry bulb temperature at the 0.4% condition. These values are then plotted on the psychrometric chart. The second condition we need to plot is our desired condition, which is the air condition after the cooling coil, and in this example, our target coil leaving condition is 7 degrees Celsius saturated air. When we plot both conditions on the psychrometric chart, we get 2 points, one at 7 degrees Celsius on the 100% relative humidity line, and the other at the outdoor air condition, which is 34.7 degrees Celsius dry bulb temperature and 70% relative humidity based on the weather data. Using these 2 points, we determine the enthalpy values from the chart, where enthalpy is expressed in kilojoules per kilogram of dry air. For the 7 degrees Celsius saturated condition, the enthalpy is 22.5 kilojoules per kilogram, while for the outdoor air condition, it is approximately 100 kilojoules per kilogram. The next step is to determine the total airflow, which can be calculated using standards such as ASHRAE 62.1, 62.2, or 170 depending on the application, and in our case the required airflow is 5,500 cubic feet per minute, which is equal to 2.58 cubic meters per second. Now we apply the cooling capacity formula, which is 1.2 multiplied by airflow in cubic meters per second multiplied by delta H, where delta H is the enthalpy difference between the entering and leaving air conditions. In our calculation, the entering air enthalpy is 100 kilojoules per kilogram, and the leaving air enthalpy is 22.5 kilojoules per kilogram, and the difference between these values gives us delta H. After converting the airflow into cubic meters per second, we simply apply the formula 1.2 multiplied by airflow multiplied by delta H to determine the total cooling capacity of the fresh air handling unit. Thank you for watching this video, and if you found it helpful, feel free to leave a comment below and share your questions.